Somewhere along the way, most of us got scared of our municipal water, of what's coming out of our faucets, and we started buying up bottled water, and a lot of it. Americans are the biggest drinkers of bottled water in the world. In 2012, we spent $11.8 billion on bottles of water. It's big business. The revenue from global sales of bottled water is about $60 billion. But do we know what's actually in those bottles and what it is we and our families are drinking? The movie we're about to see unveils many well-kept secrets about our water. It's been called one of, quote, America's best life changers. This film, Tapped, will make it impossible for you to look at bottled water the same way again. We're very privileged tonight to have with us one of the scientists interviewed in the film. Dr. Frederick von Saal truly knows about our water inside and out. Dr. von Saal is going to make a brief statement to set the stage for watching Tapped, but afterwards he is going to give us an update on what's changed since the film came out over 5 years ago. Please join me in welcoming Dr. Frederick von Saal.
Well, it's a pleasure to be here this evening, and you're going to see in this film quite a large number of issues covered, and it's going to start off with the idea, as just mentioned, people in the United States and other parts of the world are paying huge amounts of money to drink water out of plastic with the idea that this water is pure and safe, and nothing could be farther from the truth. And some of the health effects of the chemicals that leach out of these plastics are mentioned in the film, but a huge amount of research has been done since this film was made. And after the film, I'll be able to give you a little bit of an update on that. The other thing is, the reason that people think this is safe is our regulatory system is essentially incapable of dealing with this. And I have close friends who work in the FDA, for instance, and they're under tremendous pressure from administrators to assure the public that everything in our products is safe. And they know, and the administrators know, that this is not what the science shows. And so I'll give you an update on some of the regulatory events that have been going on and what should be done and what is not being done about these problems. And then finally, what this film will do is show you how unsustainable this massive use of petroleum to make plastic that is being distributed around the world in oceans. It's overwhelming our landfill. And the leachates coming out of landfill are actually full of these plastics, chemicals that are then getting into our water supply. And this is a clearly unsustainable path that we're on, and something that has to be dealt with. And so I think the best thing to do is to watch the film and then hopefully primarily have a question and answer period at the end. And I'd be happy to spend some time going over what you see in the film. So without further ado, let's go ahead and watch. So I'll make a few comments, and then hopefully they'll have the lights on and I'll be able to see you. But the first thing I'd like to say is everything that was said in this film is actually supported by published peer-reviewed science. And over the last 6 years, or 5 to 6 years since a lot of these interviews were done, a huge amount of additional information has been generated. Back in 2008, as part of the Recovery Act, the National Institutes of Health, for instance, decided to target bisphenol A because there was so much evidence that it was harmful, and the FDA was pretty much ignoring that they put $30 million into conducting research on it. And over the past 5 years, there have been about 500 publications on the health effects of BPA. And in addition to a huge amount of animal research that is going on, there are something like 90 studies that have now been done with people relating BPA to a bunch of adverse effects. And I'll just give you an example of some of them. I have an NIH grant with a colleague of mine who's here, Professor Toshi Shihoda from Harvard. He and I are studying the effects of BPA on obesity, because exposure to bisphenol A results in animals that actually are eating less, and their fat cells are accumulating more fat. And we published that first set of studies last year, and Professor Shihoda right now is working on the gene systems in fat cells that are actually allowing them to incorporate more fat than they should be. And we also see in fetuses, when exposed to incredibly small amounts, down in the low part per million range, that is a trillionth of a gram in a milliliter of this little fetal blood, can actually double the amount of fat cells that these animals end up having. So they have huge numbers of fat cells, and the fat cells get much bigger than they should. And we're trying to figure that out. So in human studies, BPA is related to obesity in children and obesity in adults. And Dr. Leo Trisandi from New York University has estimated that the extra obesity caused just by BPA in terms of lifetime will probably cost somewhere in the order of $1.5 billion because of the health effects associated with obesity. And one of those major health effects is diabetes. And so over the past 5 years, extensive evidence from animals has revealed essentially the entire molecular mechanism that BPA causes a derangement in the functioning of the pancreas, causes a stimulation of insulin secretion, and then subsequently insulin resistance, leading to diabetic state. And in fact, in human studies, BPA is related to diabetes. The really scary thing is I had talked about how this was really paradigm shifting in terms of the regulatory system. The response systems that are responsible for BPA altering insulin and causing the kind of changes that it does in the pancreas are through systems that can respond to bisphenol A at below a part per trillion. They're unimaginably small levels. And up until we came along in the Endocrine Society, part per million levels were about the lowest that anybody considered toxic. We're talking about levels 1 million to 10 million to 100 million times lower than that, because these are endocrine active compounds, and the endocrine system is programmed to operate at extremely low levels. So these effects that we're seeing, like obesity and diabetes in the human population, that are really at alarming rates of increase. For instance, the Centers for Disease Control reported recently that between 2001 and 2009, there was a 30% increase in type 2 diabetes in the United States, and horrifyingly, a 30% increase in adolescents. And this was adult diabetes when I was young. There weren't adolescents with this disease. So something is changing in the environment that is causing something to happen now that wasn't happening 50 years ago. And BPA is clearly not the only chemical that's doing this, but it is clearly part of the problem. And associated with these metabolic problems, BPA has been related in human studies and animal studies to cardiovascular disease and kidney disease, immune dysfunction, allergy, and asthma. These are animal studies and corroborated by looking at the relationship between BPA and these diseases in humans. All of this has happened over the past 5 years, and including studies of all of the reproductive damage. For instance, I've collaborated with groups that have shown that BPA damages the eggs in a female human. These are all human studies. It damages the embryos. They have an in vitro fertilization in relation to the amount of BPA. In both the mother and the father, embryo quality is reduced. The incidence of implantation is reduced. If you get an implantation, the incidence of miscarriage is increased, and the incidence of prematurity, if you get a successful pregnancy, is increased. And one of the conundrums in obstetric medicine is what has been going on that we see an increase in prematurity in what should be a well-fed, otherwise healthy country like the United States. And this is, of course, something that we see associated with chemicals. And then finally, a whole series of papers on neurobehavioral damage in both animals and now in human studies related to fetal exposure to BPA causing learning impairment in children, attention deficit hyperactivity type of outcomes, increased aggression. So these are also problems that many parents have to deal with and that are related to these chemicals. So all of this is information that we didn't have when this film was made. With regard to the chemicals that are in the plastic products that water is being sold in, an ethylene-based material, it turns out industry for years said there's absolutely no contaminants in these bottles. And it turns out that, in fact, they have the kind of phthalates that are associated with the reproductive disorders that were mentioned, substantial damage to the development of the male reproductive system, low sperm count, and including testicular cancer. And with regard to BPA, for instance, it's related to both breast cancer and prostate cancer. So we have a whole bunch of cancers caused that are related to exposure to these chemicals and caused by these chemicals in animal studies. So one of the interesting problems associated with that is that I'm sure you all see loads of products that, for instance, say BPA-free, and if they were to change the kind of plastic they were using for, say, water bottles, what would they use? Could they say, oh, this doesn't have these chemicals now, they're safe? And it turns out that, for instance, Eastman Kodak makes a product that is BPA-free, and it has taken over a lot of the market for sport water bottles, for instance. And they're very, very clever. They say the base material that this is made out of is not estrogenic. And that's probably true. What they don't tell you is, what about the actual bottle that you're drinking out of? Instead of those 3 base chemicals, 2 which 20 other chemicals are added. And so it turns out that the final product is, in fact, toxic. And I found out that this was possible a number of years ago because a corporation very quietly said, can you test a few of our products? We're really concerned, and we want to reduce exposure to BPA and other chemicals. And I said, okay. And they sent me blue bottles, red bottles, and yellow bottles. And the yellow bottles had practically no BPA in them. The red bottles had about twice as much, and the blue bottles had 3 times as much. So I called up the director of research at this corporation. I said, how do you explain this? And he said, well, we have this base material, but then we buy these dyes in a matrix, and we stir it in. We don't have any idea what the heck's in that stuff, okay? So what really matters to you is, are you drinking out of the yellow bottle to the blue bottle in terms of how exposed you are? Not what that actual initial base material was, which is what these corporations are reporting to you. You care about the product you're using. And the take-home message here is there are so many different chemicals mixed into plastics today. And you heard the FDA person say, we're not testing them. Okay, all we know is whatever the corporations tell us, and the corporations are not required to really tell the FDA anything about any of this stuff, and they don't. And there is a law, you can look it up, it's called GRAS, G-R-A-S, generally regarded as safe, which is what virtually all chemicals today are approved as safe because they haven't been tested and shown to be harmful. Well, why would a corporation do that? They have no motivation to do that. So once something's approved under GRAS authorization, like BPA and most of these phthalates were, it's virtually impossible to get rid of them under current laws. Even if the FDA wanted to, they admitted in 2010, we don't have the regulatory authority to do it. On the other hand, the Pew Foundation, 2 years ago, invited Professor Chioda, myself, and about 5 other people who were on the board of the Endocrine Society of the United States, the medical and research endocrinologists, which is what we are. We're not traditional toxicologists because we're studying chemicals that act like hormones. They control regulatory systems that control development and your metabolic systems and your reproduction and your brain and everything else in your body. And they put on a symposium where we went and gave lectures to the senior administrators at the US FDA in Washington. And we basically, on bisphenol A, saying that the take-home message was, we've got to do something about BPA and other endocrine disrupting chemicals like this because they're not being studied and regulated as if they were hormonal drugs, but they really are. And the meeting ended up with what Dr. Chioda refers to as the grouchy old man, jumping up and waving his finger in my face, yelling, literally yelling with, the whole room kind of startled. You're asking us to change what we're doing. We cannot do that. We cannot do that. And what he was acknowledging is that there is so much pressure on these regulatory agencies that once they tell the public something is safe, if they were to say to you, oh, we got it totally wrong with BPA, would you believe that they might have also gotten it wrong with something else? So again, the people that I know in these agencies say they are under tremendous pressure not to do that. So the Pew people were actually horrified by this response to the point where they immediately set up a meeting about 4 months later in Europe where multiple regulatory agencies from various European countries got together and we addressed them. same kind of presentations, and they were very responsive. And in fact, there's a lot of activity going on in Europe. And in fact, France has, as of January 1st of 2015, on the books, supposed to happen, a ban of BPA in all food and beverage contact items. And there is tremendous pressure from the Commerce Department in the United States for them not to do this. This is under our current administration, who, under pressure from corporations that make these chemicals, don't want that to happen because that's going to be a game changer. And so the situation right now is that Europe is actually trying to move aggressively to do something about these chemicals. The United States is just completely immobilized. And one of the most scary aspects of this is that we don't have any rational system for testing chemicals that are replacing chemicals we know are bad. The historic example of this is that PCBs, which were banned as flame retardants in the 1970s. Those of you who know chemistry know that there's a halide sequence of chlorine, bromine, iodine. They're very similar in their chemical characteristics to each other. And incredibly, people thought, oh, we'll get rid of the chlorine, and instead of PCBs, we'll put bromines in there. So they have polybrominated diphenyl ethers, PBDEs, that are flame retardants. Now it turns out they're, if anything, worse than the PCBs. So they're trying desperately to get rid of them. Because there was no rational thinking that went into that replacement. The scary thing here is we don't have a really good set of standards to determine what is a safe replacement. So the comment I would make is any way you can live without using plastic products, particularly plastic that comes in under any kind of heat, because heat will accelerate migration of anything out of plastic. Use alternatives to plastic. And then finally, you heard Captain Charles Moore talking about the global pollution issue. And this is a really serious problem. There's now a significant amount of data that most plastics are buoyant, they float. And exposed to ultraviolet light, the ethylene-based plastics like PET and the number 1 and number 2 plastics, and also number 4, which is the bags, low-density polyethylene. So recycling code 1, 2, and 4, these are ethylene-based, and they're responsive to UV radiation, and they fragment. And these little fragments are highly reactive and attract persistent organic pollutants, such as PCBs and the brominated flame retardants, legacy pesticides like DDT that's still floating around in the ocean, and other pesticides and organic products. To them, they're consumed by the bottom of the food chain, and once they get into organisms, these scientists are studying what is called the desorption process, the characteristics inside the animal that make these legacy chemicals actually then incorporate into the bodies of these animals. And then you get dramatic bioaccumulation by orders of magnitude up through the food chain. And so these massive amounts of plastic bottles, for instance, literally hundreds of billions, it's estimated, the last data I saw, about 20% of them are recycled. And the rest of them go into landfill and out into the environment and into oceans. And I'm sure people on beaches see these kind of things. These are fragmenting, and they are doing things to the environment that we really don't have a good handle on how much harm they're going to cause other than this bioaccumulation event is pretty scary. And so this is clearly an unsustainable situation. And so we have all of these different issues going on. We have this massive amount of petroleum being used to make chemicals that are hazardous to your health, and they're serving as global pollutants as well as impacting the health of every person in this room. So with that, I'll be happy to open things up for questions.
We'll take the first question over here.
What kind of bottle would you suggest we use for our tap water? I'm having a hard time finding a bottle that's not made of plastic.
Well, I actually, if you go to the store, there's all kinds of stainless steel bottles. The one stainless steel product that was made with a plastic lining, SIG, that lied about it, they went bankrupt. But the other stainless steel bottles have no lining to them, and as far as I know, they're what you would want to put water into. The other thing that I would say is not a bad idea is to go ahead and put a carbon filter. They're very inexpensive, and carbon adsorption of these chemicals out of the water in your home is a really good idea. And it's important to note that while your public water supply, the people who run them, and I've been at many meetings with them, and they are phenomenal at caring and trying to do the best they can, but they're not testing for these chemicals. All right, so the way to get them out of your tap water is to actually use carbon filtration. It'll be reasonably effective and very inexpensive.
Any other questions? Oh, I'll bring you a mic. Next question here.
Thanks. Has there been any progress made either on increasing recycling or any legislation that is inhibiting the companies from doing this?
Well, certainly, as you heard, the bottle manufacturers that produce these bottles have absolutely no interest in recycling whatsoever, because then they wouldn't be actually, making a new product. One of the problems with recycling is that the chemicals that are in the mix of these bottles, because none of them they're called polyethylene terephthalate. It's PET plus some unknown mixture of other chemicals. So the quality of the chemicals that are coming out of there only allow for a much inferior product to be made from the recycled chemicals. And in fact, it's so much toxic material comes out of the recycling process that there's just this huge number of ships that are constantly taking this to Malaysia and Asia, where people are paid practically nothing to live in this soup of toxicity associated with trying to extract chemicals in the recycling process. So while recycling does get rid of them in terms of them ending up in the ocean and in landfill, there are all kinds of horrors associated with it. And in fact, as far as I know, the incidence of recycling is actually not going up. The way to have recycling really work is to have a fee associated with returning these products, because particularly homeless people pick them up and use them as a source of income. And when we in Columbia, where I live in Missouri, had a deposit ordinance, the city was immaculate. It was incredible, the consequence that had on litter. So if you want to, and at the local level can do that, that's a very effective way to try to decrease the amount of litter.
Next question right here.
I started backpacking about 50 years ago and have over the years collected a number of Nalgene bottles, which I'm sure have BPA in them. What would you recommend in terms of disposing of these kinds of bottles now?
This is, actually some corporations that have done away with BPA have really faced that dilemma. What do we do with these? And unfortunately, what tends to happen to them is they tend to get shipped to third world countries. Actually, you can burn BPA because unlike polyvinyl chloride, it doesn't have chlorine in it, and it can't form really toxic chlorinated byproducts such as dioxin, all right? So one of the things you can do is you can burn non-chlorinated plastics. But if it's polyvinyl chloride, you would not want to do that.
Next question here.
I was just reading here that you say avoid canned products and cosmetics. Could you tell us a little bit more about that, please?
Yeah, so cosmetics contain the phthalates that are in polyethylene terephthalate bottles. And polyvinyl chloride can only be made with phthalates in it, which is one of the reasons, aside from the fact that vinyl chloride itself is a carcinogen in its monomer state, that you would avoid PVC plastic. But the phthalates that are present in cosmetics, particularly perfumes, hand creams, lotions, deodorants, these are, if you're particularly of reproductive age, they block testosterone. They are involved in impairing testicular function in men. And if a woman is pregnant, they're going to disrupt her pregnancy. And so cosmetics are a real problem. The lining of cans is made with bisphenol A. The only cans made in the United States that do not have BPA lining are light fruit cans, because the metal interacts with the light fruit and inhibits oxidation or discoloring of the fruit. So the can industry, the NAMPA, the National Association of Metal Packagers, tells you that without BPA lining of cans, you will die of botulism, okay, which is ludicrous. But, so at the WHO meeting, I asked them, well, how come they're not in fruit cans? And he said, well, that's because people like the taste of metal in fruit. And of course, the room got hysterical. But, the bottom line is you don't need to have BPA lining of a can. And the more acidic the substance is in the can, like tomato sauce, for instance, the more leaching of BPA you're going to have. So 3 can manufacturers in Japan in the late 90s got together and they said, the public in Japan doesn't like the issue of BPA. We'll very quietly get rid of it. And so the lining of cans made in Japan does not have BPA. So 15 years ago, an alternative to BPA existed. Although in the United States, the can manufacturers will tell you that's not true, so which is incredible. But anyway, assume if you are eating things out of cans, you are being exposed to BPA. I eat nothing out of cans, and I do not use plastic products. And I can tell you, since we have the analytical capability in my lab to measure these chemicals, the levels of them in my body are extremely low. You can make a difference in your exposure to these chemicals by some practical behavioral changes.
Okay, we have our last question here.
Hey, my question is, so I have a water filter at home, which is carbon filter, but it's plastic too. So would you recommend me to use the boil water other than the filter water then?
Well, for instance, in the Brita water filter, which is just so crazy, you put water into it, it goes through the filter into a polycarbonate container, which of course is going to leach BPA back into the water. So I haven't been able to understand the logic of them doing that. But again, there is no plastic product out there that they could use that would be guaranteed to actually be safer. That's the conundrum they have and you have as a consumer. What you can do is you can buy online carbon filtering systems that you can just stick in your water line. They cost $10 a piece online. And, or you can attach them to the faucet so that the water coming out of your faucet has gone through a carbon filter. Your refrigerator line, if you have water in it, almost certainly has one of these carbon filtering systems behind it. The important thing is if you don't ever change them, they can start accumulating bacteria and become dangerous. So you have to use them properly, but if used properly, they do make your water safer. But I wouldn't put the water into a plastic container. Put it into glass. Thank you all for coming.
Folks, thank you very much for joining us tonight. Normally, I would try to make you laugh a little bit, but I think I'll go for sending you off angrily into the night this time. So tonight we learned that the 40% of bottled water is tap water sold back to us at 1,900 times the cost, creating a multi-billion-dollar industry. Some of the chemicals in bottled water are butadiene, benzene, toluene, styrene, phthalates, and bisphenol A, as Professor von Saal just spoke about. And some of the human costs have been cancer, birth defects, liver disease, reproductive issues, obesity, and type 2 diabetes. And I think that the person I most want to prove incorrect in this movie is the man who had the oxygen tank and said, "A man like me can't fight Flint Hills." And I would like to prove him wrong and send you off with one last quote from the movie saying, "Meaningful change occurs from the bottom up." Thank you very much and have a great weekend.